derivative of trigonometric functions. So we have the derivative of sine, cosine, tangent, cosecant, secant, and cotangent. The derivative of sine, we have a cosine. Derivative of cosine is negative sine. Derivative of secant, derivative of tangent is secant square. Some textbook use 1 divided by cosine square. And then cosecant, you have negative cosecant cotangent. Derivative of secant, you have secant times tangent, and then derivative of cotangent is negative cosecant square x. So let's do some examples. First one is f of theta equals to sine of 2 theta plus cosine of theta square minus 8 times tangent of 5 theta. So let's take the derivative of that. So f prime of theta. The first one is a chain rule, so the derivative of sine is cosine of 2 theta. And then you also need to take the derivative of 2 theta, which is equals to 2. And then the derivative of cosine is equals to sine, right? And then theta square, did I miss anything? The derivative of cosine is actually negative sine. So this plus becomes a minus. And then what else? You also need to take the derivative of theta square, which is 2 theta. And then the derivative of tangent, so that is equals to secant square. So minus 8 times secant square 5 theta. What else? And then the derivative of 5 theta, which is equals to 5. So this one you can just erase the 8 and the 5 and then just put a 40 in there. All right, so that's the first one. The next one we have, let's change, let's use orange. The next one is g of theta equals to, how about cosine? We put a lot of stuff inside the cosine. I'm going to put a tangent theta to the 6th power. And I will also minus sine square. And then I will put 10 theta in there. So first of all, you have to remember from your trigonometry that sine square theta is equals to sine. Oh, actually we can use a 10 theta. So sine of 10 theta. So what is that square mean? That square means you square the entire sine. So you have sine of 10 theta and then you square the entire trig function, right? So when you take the derivative of that, you bring the 2 down. Okay, g prime. What's the derivative of cosine? The derivative of cosine is negative sine, right? And then whatever inside the big parenthesis, no change. And then you will have to use the chain rule to multiply the derivative of everything inside the parenthesis. So first of all, the derivative of tangent gives you secant square. So you have secant square, and then you have theta to the 6th power. And then of course you have to take the derivative of that as well, and then you multiply 6 theta to the 5th. And then the derivative of sine, what's the derivative of sine? The derivative of sine, you bring the 2 down, so you have 2, and then sine of 10 theta. And then what else? You also need to take the derivative of sine of 10 theta, which is using chain rule. So this chain rule, we have cosine of 10 theta, and then multiply 10. And then this entire piece is multiply the sine. So sine of this, right? Because sometimes I want to like not writing this little parenthesis to make the work looks cleaner. Okay, what else you can simplify? This one I don't see anything else other than the 10 multiply the 2, and you put the 6 theta to the 5th in front of the secant. That's all you can do. All right, so moving on to the next problem. The next problem, we have w equals to cosecant 4x plus secant to the 7th power 5x plus 2. So the derivative of cosecant is negative cosecant cotangent. So that is equals to negative cosecant 4x times cotangent 4x. Why do I leave a little space in front? Because there is a 4x. When you take the derivative of 4x by chain rule, there is a 4 in front. and then secant gives you a secant tangent, so you add a secant. Oh, by the way, no, not yet. Because let's say you have a secant 7th power, so that is equals to secant theta. You raise the whole thing to the 7th power. So you have to bring the 7th power down first. So we bring the 7th power down first, and then secant, so now it's a 6th power. And then you have a 5x plus 2. The reason I don't like to put the 6 in there is because due to one common mistake. If I write that, the next step, some people will just take the derivative of 5x plus 2, which is correct but incomplete because you haven't taken care of the secant yet. You just brought the power down. So that's why I don't really like putting the 6 in there. I will just leave the 6 outside like that. So when you look at this term, you know that, oh, then you are aware that the secant is next. So the derivative of secant is secant times tangent, right? So secant times tangent, what else? And then you have to multiply the derivative of 5x plus 2, which is 5. This one, I think the only thing that you can do is you put the 6 at this spot, and then you multiply the 7 and the 5. I guess that's all you can do. Oh, hold on, this one I will just write down for you. So -4 cosecant 4x cotangent 4x, and then plus 35, and then we have a secant 6, and then multiply one more, then you have a 7, 5x plus 2, and then you multiply tangent 5x plus 2. I guess that's it. Yep. So that's number 3. Let's do number 4. So number 4, I'm going to use a different color. So for number 4, we have z equals to cotangent 5th power, and then e raised to the cosine x. Yes, cosine x. So that is the same thing as you raise the 5th power right over here. So you have a cotangent e cosine x. So z prime, you bring the phi down. So bring the phi down, you have a 4th power, right? So this is a cotangent e to the cosine x, and then the derivative of cotangent is negative cosecant square, just right over here. Right over here, negative cosecant square. So that is, so multiply negative cosecant square, don't touch the parenthesis, cosine x, and then what else? And then you multiply the derivative of e to the cosine x by chain rule. So this is a chain rule, and then this is a chain rule. So you have the e to the anything is e to the anything, and then you take the derivative of cosine, which is negative sine x. So this one is another chain rule. So we just did a chain rule how many times? 3 times. Right? Do I recommend you to write the ddx after, like before taking the derivative? This one I don't recommend going that way. If you have one chain rule inside another, you have a problem like this, I recommend you to just write everything in one line. I do not recommend you to split up this to multiple lines. The first reason is there will be a lot to write. The second reason is it is easier to mess up if you go that way. So if you are still not familiar with the chain rule, I recommend you to go back to my previous video to study chain rule. So when you get to this point, I assume everybody can do chain rule very, very well. All right? Okay, the next problem is very interesting. The next problem, we start with something easy. We start with y equals to cosine theta. Something easy. And then what I am asking you to find is I am asking you to find the 50th derivative. What is that equal to? You don't need to take the derivative 50 times. We are going to catch a pattern. So first of all, the first derivative, that gives you a negative sine. And then second derivative, the derivative of sine is cosine. The derivative is still there. And then the third derivative, the derivative of cosine is negative sine, right? So the derivative of cosine is negative sine. So we have a minus, so that brings you to a plus sign. And then when you take the fourth derivative, you get a cosine. What do you see? We see that after fourth derivative, we go back to the cosine, right? So based on this, we can see that we back to cosine theta after four derivatives. Right? So if we repeat this 10 times, we do this cycle 10 times, then we will reach to the what? The 40th derivative. So that is equals to cosine of theta. And then we repeat this 4 more times. That gets us to the 44th derivative, that is cosine. And then we repeat this 4 more times, and then that gives me to the 48th derivative equals to cosine of theta. And then we do the 49th derivative, that is equals to negative sine. And then the 50th derivative, that is equals to what? That is equals to negative cosine of theta. So the answer is right over there. All right, we are trying to catch the sequence. How about, let's practice a sine. Let's practice a sine. Okay, so sine, let's switch to another color. So how about y equals to sine of ax, finding the 42nd derivative. So 42nd derivative, what is that equal to? So let's try to catch the sequence. We have y prime equals to cosine ax. So we have a cosine ax by chain rule. There is an 8. The derivative of ax is 8. And then a second derivative that gives you a negative sine of ax. And then you have 8 times 8. But don't multiply the 8 out. 8 times 8, I will just do an a square. And then triple prime. The derivative of sine is cosine. And then that generates another 8, so negative 8 to the third power. And then when you take the derivative of cosine, you will go back to sine. So the fourth derivative, that gives you a sine, and then that produces a negative in front, so this becomes a positive. And then that also generates another 8, then you have a to the fourth power. So we go back to sine of ax after 4 derivatives. So we are back to sine of ax after 4 derivatives. And then each derivative adds 1 to the power. What does that mean? When you reach to the 40th derivative, so you repeat this cycle 10 times, then you will reach to the 40th, right? So when you reach to the 40th derivative, then you have a positive 8, and then this will be the 40th power. And then you have sine of ax, and then the 41, you have a cosine ax, 8 to the 41st power, and then 42nd, that gives you cosine, that gives you sine of ax, but this time there is a minus, then you have 8 of 42nd power. Yep, like that. So this is the 42nd derivative. So using this idea, you might get a problem like this. So you get a sine function. They are asking you to find what? They are asking you to find the 100 derivative, 102, 103, 205, something like this. So in that case, you know what to do. You don't need to take the derivative 100 times. You won't have enough time to do that on the test. You are going to catch the sequence and then find out what happened when you repeat this cycle many times. All right, so that is the end of this video. If you like it, give me a like, and I will see you all in the next lesson. Signing out.